What's up everybody, and welcome back to my channel. I'm Flylawyer737. This is it. We are in the Zibo 737. First 737-800 stream for me on YouTube, and we are bringing today this beauty, November 8556 Zulu, from Denver to the other side of the Rocky Mountains in Salt Lake City. It's a nice day in Denver, same in Salt Lake, pretty warm here, about 13 degrees Celsius. A little bit colder in Salt Lake, if I can remember correctly, about 3 degrees Celsius above freezing. But nice weather everywhere, both sides of the Rockies, so we expect a very nice sightseeing along the route. This will take about an hour or an hour and 15 minutes from our takeoff to our landing, and it will be a lot to enjoy. So without further ado, let's jump into the cockpit and start with this flight. Okay, here we are in a cold and dark situation. First officer side, the aircraft has already been preloaded with fuel and the passenger. In this situation, we have GPU connected, chocks are in place, doors are open, and we got about 31,000 pounds of payload among passengers and cargo, and we have around 12,500 pounds of fuel. We have a requirement of 12,300. According to our flight plan. We can take a look at the flight plan here, and from Denver to Salt Lake, it's flight number 2668, Southwest 2668. Minimum required, which is also the minimum planned, equal to the maximum planned, since we are not doing any tankering, is 12,300 pounds. Flight time expected 1 hour and 5 minutes. And the route is going to be straight route from runway 25 in use from departure here in Denver to runway 34 left, if I'm not wrong. 34 left is planned as well here for our arrival into Salt Lake. So let's power up these aircraft and start our flight. So on the 737, for those of you that do not know, I'm a real Boeing 737 rated pilot. So in this stream I will be able to chat a little bit more, even though this stream is going to be quite short. It's quite short flight, but anyway, we will have quite a lot of time to talk about the 737 systems and procedures. Of course, once more, this is for entertainment purpose only. So it is not in any way supposed to be for training. So the overhead of the 737 has not changed a lot into years. Battery is the first thing. Then of course we are having a quite quick look to the flap indicator, flap lever, gear lever. Everything should be in place and matching. So when everything is okay, we just put the ground power on, and here we are. We power up the aircraft, then we can have a look at the volts of the battery, how the situation is, and the voltage, of course, of the ground power. Then the pilot monitoring is doing actually the cockpit preparation, or the first officer is doing a lot of the cockpit preparation, and the power up of the aircraft is generally done by the pilot flying, although can be task shared anyway. What I'm about to show you, the first part of the cockpit preparation, is all made by the first officer. It starts up here with what is called a rainbow check. So the rainbow check goes from one side to the other and back to the other side, so that's why it's called rainbow. First thing first, align the IRSs we have 2 of them on the 737-800 instead of 3 on the Airbus. We had done few streams about Airbus before, so now we have only 2 IRSs, and I also hope that this is going to be my first let's say professional stream for entertainment purpose. So let's back into the flight. IRSs, then we go up here to check the audio control panel. Number 3 is set. We don't want any interference on the radios with the audio control panel number 3, so we assure that the mic selector is set in the flight interphone so it doesn't bother anything. So we do the Mach overspeed and speed test, 2 channels. So we are on the right side. Then we go back to the left side. We go to the flap and slat devices check. Then we go back to the right side. We check the oxygen and we perform the stall test. Number 1 channel and the number 2 channel. Now these tests are requiring the AC power to be on and connected to the aircraft for a certain amount of time. I don't actually remember exactly the number of minutes, but for the time you are doing these checks and you go back to the stall warning test, it should be more than enough to allow the stall warning to function. These actually tests the stick shakers for the captain side and the first officer side. Then we check the alternate landing gear lights. Then we go down into the main overhead panel and we start from the top to the bottom, from left to the right. All done by the first officers. So this is the flow. Yaw damper, all normal auto. We check the cross feed valve, fuel cross feed valves, pumps off. Here we go, everything is nice and clean here. If we want to add some brightness to our overhead panel, otherwise it's okay like that. Emergency exit lights to arm. I don't know why, but I like the left switch to be all the way down, even if it's chime only. I don't know why I like it in real life as in the simulator. The aircraft has already been refueled, so we can put the fasten seatbelt signs to on. Everything is nice here. Window heat goes on, and we check the lights are on. Now, if we want, we can do a hover test and switch them off. Now the test is passed. We switch back on, and we also do a power test, switching them off and then powering up. So the tests are passed. These actually are not mandatory for my company's SOP, but in some other airlines might be mandatory for the pre-flight check. Then everything is nice and clean like that all the way. Then what will we want? Trim air. Usually we keep the temperatures a little bit lower, a little bit colder. Then the packs must be off. I'd like to have the isolation valve to auto, this closed. And for our flight today, we're going to climb to 36,000 feet, and the elevation of the Salt Lake Airport is 4,250 feet. So we're going to set it here, 4,250, auto. This is very important, the pressurization mode selector to auto, position to steady, right engine start igniter, and everything is set up here. Then we go down and we power up, or we set up a little bit of the main panel. We cage the standby artificial horizon like that. We set up the altimeter setting. Now the altimeter in Denver as per latest 80s is 3004, so it's gonna be 3004 set 1, 2 and 3 times. The first officer will be pilot flying, so the right hand flight director master comes on. Flight path vector, I want it, and also I want the airports on the navigation display, and everything is okay like that. I just put 100 feet more here to remember myself that I don't have the ATC clearance for the moment. Auto brake to RTO. Here we go with the systems, engine parameters, all looks good. Setting the clocks on UTC time. Now it's the moment for some fire tests. So we go into fault in op system, fire test 1, 2 and APU. The fire bottles, all 3 are okay. We have 2 bottles for the engine and 1 bottle for the APU. Then we have the cargo fire test, a little setup of the auto control panel, and here we go. Perfect. So now it's time to go and jump on the FMC. It says enter IRS position. Without further ado, let's program it. And we are in Denver. Gonna grab the GPS left position. This is the one we want. The route is gonna be from Denver to Salt Lake. It's already stored, so it's gonna be recalled right now like that. We activate it. We're gonna check it later. And then the flight number is gonna be Southwest 2668. 2668, that's okay. In the meantime, the IRSs are aligning, and the flight plan says, here we go, that runway 25 is in use for departure according to the ATIS in Denver today. We're gonna be cleared to Salt Lake by the Zimmer 3 departure changey. And then Echo Kilo Romeo Lithi 5 with the Salt Lake arrival. So we go into the departure page, Denver runway 25. Then we want the Zimmer 3 change of transition. As we discussed in Salt Lake, we expect runway 34 left for the time being via the Lithi 5 and Echo Kilo Romeo transition, and we don't want any other transition to be in our way. We're going to fly just radar vectors for the ILS approach. Actually, we're going to come from Plage Point, and from Plage Point we are intercepting the ILS. So that is what we are going to use. So no transition. It's going to be all like that. We're going to check for any discontinuity on the road. We have Plage, Vector, and Downlope. We're going to take away the vectors, so Plage, Downlope like that, and the route is closed. Of course, this is done because we don't have any ATC. In real life, with an ATC environment, of course, we need to take into consideration what ATC says, and it's important not to arrange the flight plan and the waypoints in the FMC by ourselves without any information from the ATC first. We have a standard time of departure 2045 UTC, by the way. It's 2041, so we are running a little bit late. I'm trying to accelerate a little bit more the procedures now. First of all, I'm going to remove some elements from the outside, and I'm going to start the APU like that. So we take a little bit of advantage, then jump back into the FMC. So now the route is done. We go into the performance initialization page. We have a zero fuel weight expected 126.1. Let's see what the ACARS is sending us. 126.0 is almost there. Reserves, we don't have any alternate for this because we can apply the 3-2-1 or the 1-2-3 rule today. So we have just the 45 minutes reserve, which is 3,300. pounds of reserve. Cost index for this route is gone to, I just can't remember where it is on the Southwest layout. Here it is, 13. And the cruise flight level is 360. Then we can arrange or modify our flight level when we are in cruise. Average wind 286.61, 286.61, a little bit of headwind. We can expect some turbulence over the Rockies today in this flight. ISO deviation +5, 5 centigrade above. Thank you for the notes. Now I think the APU is ready. We can check it. Yes, APU is delivering power. We take it. We also do start the chronometer because we want the APU to run at idle just with electrical power and no air spill for 1 full minute before we can spill some air. This is to preserve APU life. Of course, it was true for the 737 Classics. It's most true for them, and it's true also for the NGs or the MAX, even though the APU are newer and definitely much better than those mounted on the Classics. By the way, I had a lot of APU faults in the Classics and none in the NGs or in the MAX, so they have improved a lot the quality of the APUs. So now I'm performing in a separate computer some calculation for the departure for 138,500 pounds, and what it has output from the EFB says we're going to do a flap 5 takeoff 2 with no assumed temperature. So it's going to be a takeoff 2 flap 5. This of course because of the high elevation of Denver. We want a thrust reduction at 1500 and an acceleration of 3000. This is at least per my company SOP. We can reduce the acceleration and the thrust reduction down to 800 feet, but I don't want to do that in Denver since we are quite high with the elevation. The runway anyway is pretty long, is almost 12,000 feet. And we have these speeds 38, 38, 43, 138, 138, 143, so we are not limited by the runway, thanks God. We have a trim of 6.0. I'm tending to over trim a little bit on the Zibo 737 because I noticed on takeoff it's a little bit weak in pitch up, so I'm always over trimming a little bit compared to what the FMC says. Then we go back into the FMC and we need to do one more thing. What to do in case something goes wrong. What to do in case we have some problems. Okay, this is the SID we're gonna fly. The Zimmer 3 departure. It's on plate 10-3 X-ray, effective 12th of August 2021. From runway 25 we are going to take off and then turn right towards Mugby to be reached at or below 10,000. And our EFB should say us what to do in case of an engine failure during a takeoff phase here, but we don't have any EFB that is capable of saying that to me, at least in the simulator. So what am I doing? I am grabbing the ILS runway 25 and check what the missed approach procedure says here. It says continue straight, then intercept radial 306 to hygiene point and hold there, 306 inbound, right turn. So this is what I am going to set up into the FMC. I'm going to fix page, I'm going to put hygiene there, and here we go. Then I want to hold 306 right turn. So these are radial, so I need to put 126 here in order to have the 306 depicted on the map. As you can see right now in the map, I have here hygiene. Sorry, here I have hygiene, and this is the 306 I need to intercept. So what I will be doing is going to be to depart and then turn right, as depicted here, to go to hygiene and hold. Then I have the time climbing up, since I need to climb at least to 10,000. I have the time to check what to do with the FMC and plan a complete hold with the FMC itself. So, pilot flying page goes to takeoff reference, mandatory for departure. Pilot monitoring page goes to legs, also this is mandatory. Quick taxi briefing, and then we are good to go. Okay, 5 minutes already passed. I can put some air so our passengers are feeling more comfortable. This is the sequence: right pack, APU bleed, left pack, and then of course we have the isolation valve that works in auto position, so only one duct is being pressurized, is the left one, but I can open the isolation valve and both ducts are pressurized. So that's a good help for the APU to bring air conditioning to the aircraft, both to the cockpit and to the cabin. A quick taxi briefing, pushback is going to be here, and then we're gonna take Charlie November to join Golf all the way down to holding point 25, and then will be the departure. So without further ado, everything is set up. We can do the before takeoff checklist before start checklist to the line. Here we go. So pre-flight checklist to the line. Pins and covers are removed. Oxygen tested 100%. I needed to test, and it is. Nav transfer and display switch is normal auto. It is up here in the overhead, normal auto, and everything is correctly set up. Then we have window eat is on. Pressurization mode selector auto. Flight instrument Trek 172. Altimeter 3004 reading 5380. Parking brake is set. Engine start levers cut off. Taxi and takeoff briefing completed. Pre-flight checklist is completed to the line. Then what we are going to do is to remove the jet bridge. Call for pushback. It's going to be a straight pushback backwards. And then we set a squawk down here, as we should have received an ATC clearance. Our top altitude in our departure is going to be, if I'm not wrong, 230, but we have a restriction of 10,000, so I'm gonna put 10,000 for sure, because we're gonna hit this restriction first. And then onto the overhead. This is a flow done by the pilot monitoring. Fuel. Then we cross it. When we receive the information from the ground crew that the pushback truck is connected and the pin is inserted, then we can power on the hydraulics, the electric hydraulics, in this order. First the system B and then the system A, to prevent fluid transmission from one system to the other. We still have some cargo doors open, okay, there, and everything here is set up. We just need to close some doors here. Closing the cargo doors. Now everything is closed, and it's really good. We can also remove the GPU from the outside, remove everything we have. We assume that we have received the clearance to push, so anti-collision light goes on. The flow is completed, and now the cabin crews in the sim are coming to say, hey, thank you, ready. Perfect. and we can read the pre-flight checklist below the line. Fuel, okay, we have, yeah, that's that. We have 12,500 pounds with 4 pumps on. Passenger signs set. Auto brake, RTO. CU pre-flight and ACARS completed. Takeoff speeds, V1 138, VR 138, V2 143. MCP, yeah, I forgot this. You see what is important for the clearance, sorry, for the checklists. So we have V2 143. Heading is going to be 263 for our departure. 263. Altitude 10,000, and it is set. Then we go into the before start checklist. Flight deck door closed and locked. Doors and windows closed and locked. Anti-collision light is on. Transponder is set. And rudder and aileron trim is free and zero. Perfect. The checklist is completed. They have attached the area around the aircraft is clear. We can definitely push. First officer starts the timing. We have hydraulic pressure that's good, above 2800 psi, and parking brakes are released. Okay, we're gonna start engine number 2 and 1 in sequence. Leaving at 54. Yeah, 10 minutes late. Okay, to start the engine, right back off, isolation valve auto, left back off, minimum 30 psi pressure we should have. I don't know why it says like that, but we should have at least 30 psi right now anyway. But we go into the expanded engine mode. Engine number 2, start. Starting engine 2. What we are looking at during the engine start, we are looking at the N2, of course, rising. We are aiming for 25% N2. Then we need, of course, to have N1 movement. We cannot open the fuel lever if we don't have any N1 indication. Then, of course, we need to see some other items like fuel flow when we put the fuel in. So we're reaching 25%, engine start lever to E, in fuel on. Now we have fuel flow, we have EGT, the oil temperature is increasing, the vibrations are increasing.
Go ahead and set the parking brake.
Okay, the parking brake is set.
Disconnecting tow. Stand by.
Thank you. We're starting engine number 1 now. Okay, the engine number 2 is stable. Rough information 20, 40, 60, 60. Okay, these are stabilized parameters. Now we are going with the engine number 1. Starting 1, same information. N2, N1. I'm just calling aloud these data now, but in the real aircraft, all the startup sequence is done silently. Pilots are calling out only abnormalities, not normal parameters. So 25%, fuel on. What I'm looking at now is 56% N2, where the starter motor should disengage. The start valve should close. Waiting for 56% N2. Here we go. And pilot monitoring says static cutout. Okay, so the first officer says static cutout. Again, once again, 20, 40, 60, 60, stable. So we can call the ground staff and say, copy to ground, we had 2 good engine starts, you may disconnect, show us the pin, and have a very good day. When we have done that, and we know, we have seen that the ground personnel is about to leave, the first officer goes to the overhead and does this. Check the transformer rectifier number 3, check generator 1, 2, and the inverter. Then the flow starts here. Generator, probe E2 on. Conditioning, here we go. Engine start switch is continuous, and the APU can go off. Thank you very much. They have disconnected. We can set flap 5. like that and waiting for their signal. The departure is going to be an LNAV VNAV departure, I forgot to mention, so we can arm LNAV VNAV. Good, pin is in his end, so the nose gear steering is connected to the hydraulic system of the aircraft, and that's really important, otherwise we won't be able to steer the plane with the tiller. And now we go back here, checking the recoil, and now performing the flight control check. Up, down, left, right, rudder left, center, rudder right, center. Perfect. Then we go into the compact mode to keep the lower screen blank for preserving from tear and wear. And it's time for the before taxi checklist. Generators on, probit is on, anti-ice is not required. Air conditioning and pressurization packs auto, isolation valve is auto, engine start switch is continuous, recall, we have done it, checked. Engine start lever idle detent, flight controls checked, ground equipment is cleared, flaps, we have 5 planned, 5 green light. APU is off. Perfect. So the before taxi checklist is completed, time to taxi. Clear right, clear left. Let's assume we have been cleared, brakes off, here we go. Turning to the right first. Here we go, it moves. Perfect. Then we're gonna follow the Charlie November taxiway until we meet the Golf. Then we follow the Golf all the way down to holding point runway 25. So nice. We can also put the taxi light on. We didn't do it earlier because we didn't want to blind the ramp personnel that was waiting on the ramp. Okay, this is Charlie November. And then we are joining the Golf taxiway. A good taxi speed for the 737 in turns is about 15 knots ground speed, but we can taxi up to 30 knots on straight taxiways. And in my company, the flight data monitoring is triggered at 32 knots. Okay, all downhill here, and we turn left to join the taxiway Golf southbound. Here we go. Now we have a very, very long straight taxiway ahead of us, so we can accelerate a little bit more. I think also this taxiway here is downhill in the way we are using it today. So yeah, during taxi, nothing to do. There is no taxi checklist on the 737. Most of the things are to be concentrated on what's going on, pick up any taxi instructions, or being able to watch out for other traffics, especially during low visibility conditions. No paperwork is allowed during these situations. Meanwhile, we are taxiing. One note, on the 737, most 737 in the world, classic NGs, Maxes, have the steering wheel only on the captain's side, only here, not here. This is a real expensive option that few airlines in the world have both. My airline has not, so the pilot flying on the ground is always the captain, because he is the only one that has got the tiller. This is good side and bad side. especially for first officers like me. So the good side is that the captain's always is in charge when the aircraft is on the ground, and that's okay for me because I have less things to do with the aircraft, at least on the ground. But then, for example, in a kind of situation like an emergency where the captain is incapacitated, for example, and in flight, we cannot taxi the aircraft after landing. Or if the captain becomes incapacitated during taxi out, the aircraft is completely stuck where the incapacitation has happened, because the captain has the tiller on his side only, and the first officer is not able to taxi the plane using the rudder only. I'll try to show you now what the rudder effects are. In real aircraft, the real 737, the rudder has a deflection of 7 degrees. Okay, now I'm using the rudder, I'm not touching the tiller, but just the rudder. Okay, if I need to do some small adjustments, then it's enough to have the rudder. But if I need to do a 45 degrees turn or even a 90-degree turn, that's impossible. I might be able to do a 45-degree turn if I've got a little bit of speed, like about 20-25 knots ground speed, but I cannot steer for sure a 90-degree turn with the rudder only. So that's the bad point of having the tiller only on the captain's side. Back on the flight, we are approaching Golden Point Golf runway 25, and we have been cleared for lineup and takeoff. So our clearance is going to be that the wind is 120 degrees 8 knots. It's going to be on RNAV to Mugby, clear for takeoff. So these are coming on, strobe and steady, wings light on, cabin crew be ready for departure, auto throttle comes on, and the TCAS to TA array.
Have a good flight.
Thank you, have a good flight you too. And before takeoff checklist, flaps. Once more, 5 plan, 5, green light, stub trim is set to 6.2 units. Cabin call given the before takeoff checklist is completed. I will talk about why we have the flaps called twice later on in flight. So now it's time for the captain to start his timer. Pilot flying, in my case, first officer says I have control, stabilizing the engine at 40%, and then say set takeoff thrust. Hit the toggle button, and now the pilot monitoring, which has become the captain, says takeoff thrust set, and the pilot flying doesn't respond because of course it cannot check the engine parameter, it needs to look outside.
80 knots.
Checked, so now I neutralize the forward pressure on the control wheel.
E1. Positive rate.
Gear up. A nice rotation, about 3 degrees per second. Was a really nice rotation, almost like the real aircraft. As you can see now, I am centralized with the control, and the aircraft is almost perfectly in trim. I just need a little bit of amount of nose up trim. Okay, we are in VNAV speed.
1000.
1000 feet are passed, thank you. Since I'm about to explain a little bit of what I'm doing this first stream, I am putting the Autopilot Command B earlier, right now. Now I have N1 with a climb 1 there, and it's correct. Now that I have pressed Autopilot, the command B, I am the pilot flying, so I am in charge of controlling the MCP, the mode control panel. Now I need to wait 3000 feet AGL for the aircraft to accelerate. And this is done automatically in the newest version of the software of the FMC. I think after update 10.0 of the FMC software, the acceleration is done automatically. As you can see, now the speed bugs has gone all the way up to 30, and the aircraft starts to pitch down and increase the speed. Okay, flap 1, speed checked. Flap 1 set, and now flaps up, speed checked. Flaps up, no lights. Now the pilot monitoring does this flow. When engine anti-ice is not used, like now, it's 1, 2, checked, 3, 4. Flow is done. Flaps up, no lights. 1000 to go. Let's assume that we don't have any restriction. We want to climb 360 without any restriction. So we say climb level 360, altitude intervention, and here we go. N1 VNAV speed, the engines are back to climb thrust, and we have only cancelled the restriction at 10,000 at MUGB, but we now have the restriction at 12,000 at Ralphie. But of course, as you can see, it's a restriction says at 12,000 or above, so it's not limiting for us because we can be above 12,000 at that point, so it's not a problem for us to have this restriction in place. If we would like to get rid of this restriction as well, if I press altitude intervention push button again, then this restriction will be gone. Okay, we have already passed 10,000. It doesn't mean anything in Denver because it's an elevation of about 6,000 feet. So we keep climbing, but the aircraft has already accelerated. So what we can do is turn our external lights out, including the wing light, and set the climb mode to full climb. Now I'm climbing climb 1 to save fuel, for example, but I've been cleared already to flight level 360, so I want to climb fast as possible. I go to N1 page, delete climb, but now as you can see the thrust levers have advanced all the way and I have full climb power, blasting up to 36,000 feet at full engine power. Otherwise, the engine are flat rated until 15,000 feet, so they are climbing like in climb 1 or climb 2 mode until 15,000, and then at 15,000 they have the possibility they are taking back the full climb power, and this happens automatically. If I want to climb faster sooner, because I've been cleared about 15,000 feet earlier, then I just go here into the N1 page and delete the climb 1 or climb 2. What I can suggest is, in case I was in climb 2 and I want a full climb blast, then first I swap from climb 2 to climb 1, and then I delete the climb 1 restriction in order not to increase the power of the engine too much in one shot to preserve engine life. Then what I can do is to go to the fix page and delete the pre-built fix that we used for a contingency procedure in case of some problems during the departure, because we don't need it anymore for sure. Then here we go, climbing at 36,000 feet. We have an optimal altitude actually of flight level 390. I guess 390 is going to be a little bit too much for this route. Despite it is even a odd level, we need an even level going west. So clouds, sorry. So first 1, 2, and engine anti-ice on. Yes, here we go. Tie in green, so we have engine anti-ice, and that's good. Transition, set standard, and here we go. We can also run the after takeoff checklist because I forgot. Engine bleeds are on, packs auto, landing gear is up and off, flaps up, no lights, altimeter are standard, set and cross check. After takeoff checklist is completed. Going up in the row keys, and what was saying? I was talking about. I don't remember actually. I was talking about the D-rate climb maybe, but yeah, this is the philosophy behind. No more clouds, nice. So engine NTIs can come off, engine star switches to off, so nice. What can I do? What was about to check was the cruise level. Yes, now I remember. So I can check here on the map where top of climb and top of descents are. So top of climb is here in about 80 miles, and top of descent is here in about 320 miles or 300 miles. So I think 360 is definitely good because we also have headwind, and as we climb higher we got stronger headwind for sure. So we're gonna stick at 360 for this sector. Then I'm going to declutter a little bit the screen, the navigation display, switching off these things. You can see that there is a little bit of turbulence already now. It was expected on over the Rockies, some turbulence. Yes, that's it. And when we were about to take off, I said that I would have delayed the motivation or the information why we were calling for flaps twice. Now that we have a little bit of time, or we can explain this a little bit better. As you can see in the checklist, we have the call for flaps here in the before taxi checklist, and it says as required, and then we have the call again down here in the before takeoff, flaps dashes planned dashes green line. Why? The first says as required, the second says planned green light. So the first one, the reason why it is inserted twice, it's because in my company as well, and in other company worldwide, there have been cases where pilots have tried to take off without the flap correctly set for departure. So that is an enforcement of the safety, because there are two separate checklists that are calling for flaps, and this is a safety reason. The second reason is a procedural reason, and the procedural reason is that we might be dealing with de-ice, especially in winter, especially in these areas like Denver, Salt Lake, or Northern Europe, or even Chicago can have snow during winter. Is pretty common. So the 737 de-ices with the flaps up. So that's why it says here in the before taxi flaps as required, because I might have the need of taxi to the de-icing pad without flaps extended. Then I de-ice, remote it there, and after I need to extend the flaps for takeoff. So that's why it is another call here saying flaps. Now I need to have those. I need to have, for example, 5 planned, and I'm going to read what I was putting into the FMC, like 5 planned, and then I read a gauge here, 5, that both are matching, and I check the light, green light for example, and it needs to be green, the leading edge device light. Okay, that's why it is repeated twice. Not exactly in the same way, almost the same way, but it is important. Then what I can show you is, for example, that I have on the back of the checklist, I have, for example, before de-icing checklist, as you can see, and the after de-icing checklist. Now this is another enforcement of safety for flaps, because now here in the before de-icing checklist they are called to be up. You must have the flaps up before de-icing, and then after de-icing the flaps must be placed so as required, in this case for departure, required for departure. So as we are climbing through flight level 300, the weather is getting nicer and nicer, and we can enjoy a nice view over the Rockies Mountains. Here we are just north of Eagle County Airport. We should be able to see Eagle County on our left hand side really soon. This is still the area around Denver. Still need to have a little bit of time to meet Eagle County Airport. Anyway, let's have a look at our timings, because we have an expected arrival time 22:15 UTC, and we plan landing at 22:09, so we can be on time at the gate. 5 minutes taxi is quite reasonable in Salt Lake, landing northbound, so we might be at the gate on time. Taking into consideration the fact that almost in 99% of the airlines worldwide, if you do 3 minutes delay, it doesn't count as a delay. So we are covered until 22:17 UTC actually, without counting any delay. But the route is pretty short anyway. We are already halfway into the flight, almost halfway into the flight. We still have about 35 minutes left or 40 minutes left for the flight. So let's go in the outside view. Watch out for your ears. Here we go. Outside view over the Rockies. Really nice, beautiful. Yeah, Eagle County Airport should be somewhere here. We should be able to see it. Maybe here? Maybe. Can be. Let's do another way. Let's jump into the captain position. Let's jump into the captain seat and try to identify where the airport is. I think it's here. Should be, maybe. But it doesn't look like. Or maybe it's even closer, so I'm not able to see it here because it's quite close. But somewhere in this area it is for sure. Yeah, there I guess. Here it goes. Yes. Where we were looking at the beginning, but it was too far away, so the airport was not depicted, was not loaded yet. There we have Eagle County Airport. 1,000 to go. Let's jump back into the first officer seat to monitor the level off. This is quite important task where also workload needs to be minimized, because we want to be sure that the aircraft is actually leveling off at the prescribed or preset altitude. So we got FMC speed, VNAV path, call out aloud from the pilot flying, and as you can see, the vertical speed is reducing, the aircraft is leveling off, and the engines are going to cruise mode. Now, what my suggestion is in this situation is to go into the FMC, into the N1 limit page, and modify the parameters from auto to climb. Now, as you can see here on the upper ECAS, we have climb mode. Before we had cruise. Why this? Because if for any reason we are encountering a severe turbulence during cruise and the aircraft is losing airspeed because of the bumps, the auto throttle is of course kicking in to try to keep the speed, and if we have the N1 limits set to auto in cruise mode, we have only 96.8% of engine power available for the auto throttle to kick in. If we set climb, now we have 99.3%, and we can use this power without any time limit. So why do we need to save 4-5% of N1 power if that is going to save us from a stall, for example, due to turbulence? So that is my advice in cruise. And another thing to do right now would be to put the transponder into below mode, but this transponder is the basic one, so it doesn't have an above and below mode. And then here we go. Here we are in cruise. We have about 166 miles to top of the Seine, which means about 25 minutes to top of the Seine. Is pretty short hop from Denver to Salt Lake. Anyway, the view is fantastic. Not a cloud, not a single cloud. Definitely nice, quite good visibility. And these are a very nice day. There is not too much turbulence as well. It's pretty decent. Anyway, I guess the expectations or the forecast were for a turbulence more severe than this. But as expected, we have about 60 knots headwind. Yes. So we have a ground speed of only 379 knots, despite we are pushing at about Mach 0.76. We are not late, but as you can see, we have already lost 1 minute. It happens. It happens. We can also push a little bit more. In case we are delayed and I want to have a little bit more margin on the arrival, I can go here into the index performance and increase the cost index. All the airlines in the world have tables of cost indexes that can be used, for example, in case the aircraft is running late and the aircraft is not at the last leg of the day. So if the aircraft is running late, then it has a few more legs to do by the end of the day. Then the delays becomes bigger and bigger, and we do not want that. So what I can try is, for example, is to push, I don't know, in my company we have in case of heavy delay, we have cost index 80. We can go all the way up to 80. Let's have a look at what happens if I go to 80. Of course, I need to take into consideration fuel consumption. That's really important, because sometimes these high cost index can affect my fuel consumption really deeply. But yeah, I put 80, execute, and the speed goes all the way up to 0.80. take into consideration that the 737NG has an MMO of Mach 0.82. So we are becoming really close to that right now. And I also need to take into consideration the fact that during some cruise with turbulence, updraft or a downdraft can easily make me exceed the MMO if I'm already cruising at Mach 0.80. So I need to take a lot of things into consideration before saying, hey, I'm going to Mach 0.80 because I want to recover or catch up some of my delay. What I've earned 3 minutes. Okay, has 3 minutes so big importance for me? It depends. It might be 3 minutes are a difference between being delayed or not, or no, it doesn't make any change for me, so I don't really want to cruise at cost index 80. So I can have a halfway. So 40 is a cost index for low to medium delays. And now let's have a look at the fuel, for example. Not too much at the speed, but at the fuel. With cost index 80, I'm planning to land in Salt Lake with 5.5. If now I go 40 and execute, I land with 5.4, it says. That's strange. I'm not really believing it, because we are going slower, the fuel flow is lower, and it says that we are burning 100 pounds more. That's not really realistic. Most probably it will update itself in a few minutes. Now it has already gone up to 5.5. Maybe it will also go to 5.6. It needs a little bit of time to recalculate. In the real aircraft, it is almost instantaneous. But yeah, of course, we can allow a little bit of time for considering that with 40, I'm cruising at Mach 0.77, and I have earned 2 minutes. So I think 40 it's a good compromise for being delayed as a cost index for delayed flight. Good. Let's see, where are we? We are almost hitting the 80 miles for the top of the descent point. So we need to do some briefing. We need to perform some briefing for our approach and landing, set up a few things, and this is the way it should be done. So usually pilot flying starts the briefing around 80 miles from top of descent in normal circumstances. In some abnormal circumstances, like for example landing in a very heavy traffic airport in Europe or in the US, then the briefings and the setup must be anticipated to 120 or 140 nautical miles to allow plenty of time to do the briefing, to do the setup, taking also into consideration that in such airports ATC must or can ask pilots to descend quite earlier than they expected or from their calculated top of descent point on the aircraft systems. So since I'm going to explain a few things, let's start the briefing first. What the pilot flying is going to do now is to pick up the charts first. So these are the Denver charts. I don't need them anymore. I want the Salt Lake. So let's go into Salt Lake. Also Salt Lake, of course, is more than 4,000 feet high, so it has a quite interesting situation with the density altitude, especially during summer, definitely. I want the airport plate, I want the parking gates plate, and then I want the arrival, that is going to be the Leahy 5, and then I want the ILS. Let's cross-check the weather once more in Salt Lake, still in use 34 left, 34 right, or DME 35. I can also have another look here from the data link. If I check in the AOC request, weather request, I want the weather for Salt Lake City, and I send it. Now I got it, and it says 2805 knots, so it's gonna be almost crosswind, 7 miles, view 20,000, 2 degrees, -3, 3018. So that's it. Okay, so that's what we're gonna do. Runway 34 left confirmed in use. Going back to my EFB, going into the arrival, sorry, no, in the approach, and ILS 34 left. This is what I want. So let's have a look at the arrival first. We are coming from Echo Kilo Romeo, Meeker VOR. Then we're gonna fly Mython, join Spain, landing north, expect 16,000. So what I'm about to do, this is an expected altitude, not a cleared altitude from the star profile. So I'm gonna go to Spain into the FMC. Spain, it says 196. That's definitely too high for us. So I want here 16,000 to be in line. If I do that, now my top of the descent will become closer to my aircraft. See, it has become slightly closer than before. Okay? Then what I have after Spain is to fly Leahy. Then it's gonna be Blue P 12000 or above. Here we go, 12000 or above, then camp at 1000, yes, then plage, and then we have expect vectors to final approach course, runway 34 left or 35, okay? And that's why I just linked plage with Dunlop, because we don't have any ATC, so I expect to be a direct route from plage to Dunlop for landing into 34 left. So landing 34 left, this is the plate 11-4, effective 22nd of April 2021. We have India Uniform Hotel, a localizer with DME, I guess, yes, ILS DME 111.9. Going down here, 111.9. 1 and 2, 111.9. Differently from the Airbus, the tuning of the radios in the 737 is all manually done. Then I want also as a backup the Wasatch VOR. It's 16.8. I put it on standby. 16.8 and 16.8 here. Then what do we have? Final approach course 344. Going to the MCP and setting 344 in both courses. 344 and 344. Here we go. Then at flag we must be at 6100. Let's check it out. Flag, here we go, 6100. Then we have a 3-degree glide path, and I'm pretty sure this is what do we have also here. Down here, 3-degree glide path, that's correct. down to the minima of 4429. 4429 is our minima, and I'm setting it up here. Minima, baro, so based on the barometric altimeter, 44, yeah, 4429. 4429. In the real aircraft, this is not a spinning wheel, okay? This is just like here in the Zibo, okay? It turns a few degrees one side and other side, and then it changes the altitudes, the minimums, okay? It's not spinning all the way. It's not 360 degrees free spinning. And the touchdown elevation is going to be 4229, aerodrome 4231, and it's okay for our pressurization system. MSA based on the WASACT VR is 12.7 south, 11,000 north, 86 the western part. DME or radar required for arrival at Puter, simultaneous approach authorized, the vertical guidance system and ILS glide path not coincident. And that's understood. What we're gonna do is to fly to Dunlop 8000, descending then to 6100 to flag. This is our final approach point. 3 degrees glide down to the minima of 4429 with a minimum RVR of 1800 or half-mile visibility. That's not an issue today, but it's worth mention. Puppy left-hand side, approach light system sequence 2. See, these are the sequence flashing 2. And in case of missed approach, we are climbing 4800, climbing left turn 8100 outbound on radial 249 of WASACT VR to Stacco intersection, 20 miles from WASACT VR and hold. And this is the holding depicted, and we should have the same information here. Climbing 4800, then 8100 Stacco, hold at Stacco, and we have the hold here, 069 with left turn. 069 left turn. That's good. What's next? Next thing to do is to check the ground taxi and the parking area. So we're gonna land here runway 34 left, planning to vacate most probably Alpha 7 or Alpha 8 to the right. Then we're gonna taxi via Alpha or Bravo down to the new layout of Salt Lake. This airport has this layout since about 1 year. These old terminals are being dismissed, and there is a continuation of the B concourse up here and a continuation of the A concourse here, more or less like Denver is nowadays. In the scenery it is already completed. In real life it's not. In real life the status of the airport is as depicted in the chart here. And our assigned parking spot today is Bravo 18. So Bravo 18 is here. Bravo 18 in the B concourse via the north taxi lane to west. So we are expecting to go southbound via Alpha or Bravo until 2 West, catch the 2 West taxiway into Bravo concourse and park at Bravo 18. So that's the briefing for the route. Now we have the performance briefing. Performance-wise, we need to take into consideration the fuel. So we have 5.676 now we have on board, 5.6 landing in Salt Lake, so we have 2,000 pounds difference. 2,000 pounds difference means 131.6, 131.6, let's put it here, 142 knots. As you can see, there is almost always a 1 knot difference between the actual landing speed when we are usually performing the briefing near the top of the sand and the landing weight. So it's of course pretty little difference, but anyway, 142, flap 30, standard wind correction since I guess latest wind in Salt Lake is crosswind, yeah, 280 at 7 knots. And that's it. And now we need to go into VNAV, next forecast, and put something here into descent forecast page. What I need to put here is the descent winds. I'm going here in the briefing package and grab the descent winds. Here we go. Here we have a few of them. Usually we take 300, 180 and 9000. So 300, 180, 9000. At 300 is 280, 67, 280 at 67. Then at 180 is 270 at 40, 270 at 40. Then at 9000 is 230, 13 knots. Good. Execute. This will help to have a better calculation of the vertical profile during the descent, taking into consideration winds. Then I need to go back here, check the ISA deviation was +5. The expected ISA deviation was +5. It's almost there. Yes, +5. So ISA deviation 5, and the altimeter setting into Salt Lake is 3018. 3018. There it goes, and execute. This also helps to have a better calculation of the top of descent when we are going to change the altimeter setting from standard to the local QNH in Salt Lake. And I'm going to preset here 3018. 3018. This is a very nice feature of the navigation, of the primary flight display of the Boeing 737NG. I can keep my standard setting. Meanwhile, I preset the local altimeter setting in my destination airport. So when I pass the transition altitude, or when they clear me to an altitude, I just need to push here and it will change automatically to the local altimeter setting. Pretty nice. Then I have done everything except one thing: the considerations for the landing. Runway is pretty long because we have something like, here we go, 12,000 feet runway. Temperature is not that high, is 2 degrees. So I guess an auto brake 2 will work. I will land, of course, manually with idle reverse. Idle reverse, it's about 25-30% and 1. In the simulator, I'm not really able to set such a low value, so my reverse will go around 50%. It's where in my joystick I have the detent, but of course in a real situation I would go more or less for idle reverse. The real 737 has got 3 reverse detent. The first one is idle, so the detent, the reverse levers are just coming out from their stowed position. Then we have detent 2 reverse, which is almost halfway, and then there is a little click that puts the reversers into the detent 3, which is the maximum reverse, and they push, if I'm not wrong, up to 78% and 1. That's the maximum reverse they can achieve. And of course, especially above 80 knots, 80 knots is the difference, is the boundary speed where Boeing has decided to have low energy flight below 80 knots, high energy flight above 80 knots. So reversers are really most effective when we are above 80 knots. Then under 80, brakes become much more effective. If we are going to brake immediately after touchdown, then the problem would be to have a heat up of the brakes that is going to be almost uncontrollable. So it's much better to apply reverse, let the aircraft to slow down using the reverse at least until 100 knots and then brake. Of course, what we're gonna use today is the auto brake. My company SOP says we can use auto brake if we want, or we can also land with auto brakes off. In some cases we do, especially when the runway is dry and the weather is nice, the runway is not contaminated, there is no low visibility, there is a long runway, and sometimes we also need to vacate at the end, so we can land with auto brakes off without any problems. Yes, approaching top of the sand, we are like we're 9 miles from top of the sand. So let's assume that we request to the ATC to descend and they clear us to 16,000. So we set 16,000 there, 16,000 set, and then we hit altitude intervention. Then the aircraft goes into the descent mode. Now it will descend 1,000 feet per minute until the vertical path is met. And then it will continue to descend on the vertical path. This is also nice, not only because we are sure to be on the path when it will be met, but because we are slowly reducing the engine power from a cruise situation to a shallow descent situation to an idle situation. Going all the way from cruise down to idle is really not recommended, because the engines are going from maybe 80-85% of power down to 40 with an outside temperature of maybe, I don't know, minus 60, minus 55. So the components of the engine can be damaged quite heavily in this situation. So it's always recommended to have this transition in between cruise, shallow descent, and then descent. Same things apply for the cool down after landing. If we do not use more than idle reverse, then we can consider 3 minutes cool down from the moment when the engine are retarded to idle during the flare. If we are using more than idle reverse, then we need, of course, to consider 3 minutes cool down from the moment when we deselect the reverser, so when we stow the reversers after the usage. But in any case, no way that we can shut down an engine on the ground without cooling it down first for at least 3 minutes. That's really important. 3 minutes cool down after landing, and 2-3 minutes warm up before setting takeoff thrust. Good. Here we go. As you can see, 1,000 feet per minute, more or less, and the path is approaching. Now it's 2,100 and reducing. That means that our profile is actually meeting us. As you can see, sorry, my mistake, I have done a little bit of scratch. Okay, as you can see from the vertical situation display, the profile now is below us, but we have such a shallow descent that we are going to meet it, and then our descent will become much pronounced in order to keep the path. So less than 1,000 feet below the path. Now there will be one pointer, as you can see, retard. So now the engines are going to idle. The auto throttle is retarding the engine all the way to idle, and the vertical speed is increasing. The path is matching the center of the scale, And of course now the white bar has become steeper because now we are descending steeper than before to keep the path. Then of course the auto throttle is always helping the engine and the profile to be stable. Now they are retarding again. So in real aircraft, 99% of the time it's well calculated, and you have this throttle completely closed, and the aircraft is just descending at idle power, staying on the path. Sometimes if you have strong headwind, then a little bit of thrust is required. Sometimes when you have a strong tailwind, you need to play with a speed brake in order to help the aircraft to descend, because it's moving faster than the flight management computer thought. So you always need to be aware of the tricky situation that can come up with a descent. The energy management on the 737NG, especially this one, especially the one with the splitted scimitar winglet or with the banded winglet, is important. You have a lot of energy to dissipate, and it takes miles, it takes time to dissipate this speed, this energy, and of course this must be taken into consideration when planning the descent and the approach phase. On the other hand, for example, if you fly a 737NG without winglets or a 737 Classic without winglets, you will notice a smarter approach to the energy management. So the aircraft are getting and losing energy in a faster way than the NG, for example. The 737 MAX is another thing again, because it has a different winglet shape. So the winglets of the 737 MAX also are helping a lot for stability, for turbulence dissipation. So they are also helping not only for the classic winglets item like fuel saving, reducing the induced turbulence or the induced drag, sorry, and more comfort for passengers and crews, etc., but also are increasing the stability of the aircraft, especially in turbulent or crosswind conditions. So here we go, approaching Spain, expecting 16,000 as briefed. I forgot to do the descent checklist. Now it's time to do that. So we can go back, chart, and descent checklist. Pressurization, landing altitude set. We have checked it twice. Recall, check. Auto brake, level 2. Landing data, we have a VREF of 142, minima 4629, and approach briefing completed. Descent checklist completed. So here we go back to the approach plate, sorry, for the arrival plate. Here we are, bound Spain. Then we're gonna go Leahy, Bloopy, Camp, Plage for the ILS 34 left. Very good. As we are approaching the ground, of course, there are also the mountains profile shown here into the vertical navigation display. This is really helpful, especially in IMC conditions. We are approaching the Utah Lake here, and down there in distance there is the Great Salt Lake, where Salt Lake City is. Look at these beautiful mountains. Looks definitely real. Good. So we have passed Spain. Next we have Bloopy at or above 12,000. So that is the next step in our arrival. And of course here is always important to keep the heading bug aligned with the current heading of the aircraft at all time. So we are passing almost the transition altitude, descending 12,000, so we can set the altimeter 3018. Approach checklist, it only says altimeter, so it's 3018, 3018 and 3018 cross-checked. And the approach checklist is completed, and now we can also do, oh sorry, I forgot to switch off the fasten seatbelt sign. Oh my god, I think that our passengers will be really disappointed by that. Few lights. I have to really apologize to my passengers for this. In a real flight, of course, the cabin crew would have ringed in the cockpit saying, oh, you forgot to switch off the fasten seatbelt sign. Really nice visibility today. It's amazing. Let's have an outside view for a while. Utah Lake, Provo City, and the Great Salt Lake down there in distance. Beautiful shot with the mountains in the background. Really amazing. Let's jump back into the cockpit. We are approaching Bloopy. Our next step is now over Bloopy. We can descend 1000 to be kept at camp. The lower we go, and of course the higher the mountain profile becomes on the vertical situation display. Now, if we zoom a lot here in the navigation display, you can see these two green circles. One where is written decel, the other one without. These are the deceleration points pre-calculated by the FMC. Okay, 1000 to go is checked, monitoring the level off of the aircraft. So the first circle here after camp is the first deceleration, where the aircraft is decelerating towards 250 knots, but we will find written 240. As you can see, it has already begun to decelerate by itself, slowing down until 240 knots, and we can meet it also here in the VNAV page of the FMC. Speed restriction 240 by 10,000. At camp, 244 knots at 1000, then we have another restriction, 6,100 at downlope, and that's what we're gonna do. We're gonna descend 6,100 feet to be reached by downlope. VNAV alt, we don't like it, we want to VNAV path, so we press altitude intervention to go into the VNAV path mode. The aircraft starts to descend. Now as you can see, we have gone a little bit higher on the profile. The aircraft has a little bit of mixed up with the throttle. I need to help with the speed brake in order not to increase our speed too much. Okay? Sometimes it happens. Sometimes it happens in real life as well. Okay, we are recovering the profile, recovering the speed. This is nice. And the next step after downlope will be the approach. We have been cleared for the ILS, so we are 18 miles out, a little bit too much to arm the approach mode. I'll wait a little bit more till 17 miles. In the meantime, the aircraft is going to decelerate once more towards the up speed, minimum clean speed. Then after flag at 6,100 we need to catch the glide. The localizer is coming, 16.3 is good, arming the approach mode is armed, lock green and glide slope white. So the lock is captured, is green, so 344 goes on the heading, speed is good. I retract the speed brake and start to extend the flaps. So flaps 1, we have a fantastic flap profile helping us to decelerate, even though the flaps should never be used for deceleration. Flap 5, but having the possibility of extending flaps until 250 knots, it's amazing. It's really so helpful. So the glide slope is captured, as you can see here. So we put the missed approach altitude 8,100 here. The runway should be in sight. There it is. Perfect. There we go. I can remove the vertical situation display. Very nice. We are smooth and nice on the glide path, and on the localizer we have a little bit of tailwind, so the aircraft is not really decelerating that much, but we still have time. We have a lot of time to play with. The wind should turn from the west in the lower part of the approach. Let's see if we can remember to keep an eye on the wind when we are below like 500 feet. That's good. Radio altimeter is alive. So gear down, flap 15. Let's continue to reduce the speed, and now we go like that. Cabin crew, please prepare for landing. We arm the speed brake like that. Checking one more our approach speed. VRF is correct. Flap 25. And flap 30, 148. It's a little bit turbulent, so I keep 1 knot more than planned. Okay, and landing checklist. Landing checklist. Cabin call given. Engine start switches are continuous. Speed brake armed. Landing gear is down. Flaps 30 planned or 30 planned. 30 green light. Landing checklist completed. We are clear to land. Runway 34 left. Wind is 280 degrees 5 knots. Planning to vacate at Alpha 7 or Alpha 8 in the worst case. Okay, 1,000 feet stable. Missed approach altitude is set, and continue. Contact. By saying contact, the pilot flying tells pilot monitoring that no other call-outs about altitudes or minimums altitude are required, because pilot has already the runway in sight. Okay. Disengaging autopilot and auto throttle.
500.
This, of course, is going to be a manual landing as briefed.
Approaching minimums.
Now, the wind is calm,
Minimums.
and since we are visual, I am accepting a deviation with 3 reds on the puppy in order to vacate the runway quicker. 1 dot is okay, it's okay like that. Let's go down. So nice.
50. 30. 10.
So nice. Here we go. Speed brake up. 2 reverses. 57%, as I told you. But this would count as idle reverse. Then next calls are
80 knots.
checked. And 60 knots. Here we go, vacating to the right. Auto brake off. What am I getting? Alpha 7, amazing, as briefed. Slow down, slow down, slow down. Slow down, taxi speed, that's nice. Then we're gonna get the second one, the inner taxiway, the Bravo one, to taxi to the gate. Then there is the after landing flow done again by the first officer, because on the ground the pilot flying is always the captain. So the captain triggers the after landing flow by raising the speed brake lever, and then the flow goes like this. It starts on the overhead. It's not easy to do it meanwhile taxiing as well, but probe to auto. Here go to steady, off, off. I need to see where I'm going, otherwise it would be a mess. And then taxi light on, landing lights off, and speed brake. Okay, in, trim 5 units, and transponder to altitude reporting off. That's it. That's the after landing. To complete also we have flight directors off. Wind back the speed, okay. Then we continue straight. We need to catch the 2 west taxiway. As last thing, we can reset the minimum and take away the ILS from the navigation radio. So welcome to Salt Lake City. I hope you enjoyed the ride, enjoyed the procedures on the Boeing 737NG. It's a wonderful machine, an amazing one, even though it has been stretched. It has been stretched too much with the MAX variant, definitely. But I really hope now all the problems of the MAX are gone, so we can focus on a nice and bright future for all 737 around the world. We can start the APU. Captain gives the command and first officer executes it. Here we have taxiway 2 west north. It's the one that we are supposed to catch. And then we go to parking stand number Bravo 18. To better understand where the Bravo 18 is, since all the gates here have a marshal, I am using SAM with the follow me tool. Oh, sorry, no current taxi network defined. Okay, so we need to find it by our own. The Bravo 18 gate is going to be the 3rd or the 4th from the end. but it's not going to be really easy to understand where the end is, because in the scenery here the terminal goes all the way down. It's not unfinished like in the real world, so I have to go outside and check by myself more or less where stand 18 can be, Bravo 18. I guess it should be more or less in front of this hangar here, so maybe this one or the next one. Let's take this one. I'm not sure which stand is this, but let's assume it's Bravo 18. So taxi lights off, APU is available and on bus, and let's park. From the outside is always easier to park, a little bit more engine, otherwise we're gonna stop. Good. And waiting for the marshal signals something like this. I guess it's more than enough, even though the marshal says it's not, but I'm happy with that. Okay, so we are at the gate. Now what to do? APU is on the bus. It's more important to have the APU on the bus, because now we're gonna do is number 2 cut off, seatbelts off, number 1 cut off, and then on the overhead the first officer goes with the flow. Fuel pumps all off except one for the APU. Hydraulic A and B on the other side, inverted sequence, first A and then B. Then we have packs. If we want to give some air to the passengers, we can keep the isolation valve open and then give air via the APU bleed. Wing light off, anti-collision light off, and check here that everything is off. Then we have to stop the chronometers, the timers. Here everything is set. Then last thing, go to the transponder, put back 2000, the standard IFR code, put it on standby, and then it's just a matter of time when the jet bridge is going to be connected. The ground crew is approaching the aircraft for offloading. Doors are open, GPU is connected, chocks are set. And as soon as the GPU is connected, of course the hydraulic pressure is dropping. That's correct as supposed to be. And as soon as the GPU is connected, what we can do is just to check the GPU current and volts, select the GPU, turn off the packs, isolation valve to auto, GPU is on, APU off, and the fuel pump off. And now we can read the shutdown checklist. Shutdown checklist: fuel pumps off, probe auto, hydraulic panel is set, flaps up, parking brake set, engine start lever cut off, weather radar is off, technical log completed, EFB completed, shutdown checklist completed, the flight is over. Here we are during offload in Salt Lake. Thank you very much for being part of this crew today in this flight. It has been a pleasure for me. I hope to have the opportunity to transmit something to you, to give some knowledge about the 737 systems and procedures. Thank you very much for your support to the channel. If you haven't hit the subscribe button, please do it. It's a real important thing to continue the channel in time. I'm FlyLord737. Thank you so much once again. I will leave you with some cinematics from the landing in Salt Lake. Have a great day. Thank you so much. Take care of each other and see you.